Okay, here we want to use the disk method. The disk method is a method that we use in calculus to find the volume of a solid of revolution. We can go about the x-axis or the y-axis. This is something that we use a lot in engineering and manufacturing, things like that. Because remember, when we're dealing with volume, we always are trying to make things lighter, smaller, more compact, but still have the same capabilities. All right. So our formula is the V, that's volume, is equal to pi, then the interval from A to B, R of x squared. So that tells us that this is a definite integral. All right. So first, let's look at a problem. Let's use the form y is equal to 4 minus x squared. Okay, now the first thing we want to do is try to draw a picture of this so we can get a visual representation of it. So this will look like this. Now, one thing we know that it's x squared, so that's a parabola. This is negative, so it's opening downward. And the y-intercept is 4, so we have to use all of that. So the area, the volume and the area that we're looking for is everything in this area. And what we want to do is basically to rotate it about this x-axis. All right, that's very important. Okay, now we're going to come back to the formula. All right, V is equal to pi. Now about the x-axis, this goes from 0 to 2. Now that's going to be important for what we look at later. For this one, it goes to 0 to 2. And our function is 4 minus x squared squared. Now remember, we have to square that. That's part of the function. Now, one thing I want to do, and I'm going to erase this later, but I do want to show the actual work. So we have 4 minus x squared times 4 minus x squared. And as soon as you see this, you're going to see the FOIL method. So, of course, our first terms are 4 times 4, which is 16. Our outside terms, that's negative 4x squared, then minus 4x squared, with outside and inside. And our last terms, negative and negative, make that a positive. So that's plus x to the 4th. This simplifies to 16 minus 8x squared plus x to the 4th. Now, one thing that I'm going to do, if we remember, anytime we're dealing with polynomials, we want to try to write this in descending order. So I'm just going to write this as x to the 4th minus 8x squared plus 16. Now this is the same thing. I just wrote it as a polynomial in descending order. All right, which is just a standard way that we do it. Now I'm going to come back and erase this since we have it. I just wanted us to actually see the work done. So now the first thing we need to do is we need to find the antiderivative. The antiderivative of x to the 4 is x to the 5th over 5 minus 8x to the 3rd over 3 plus 16x. And we have to evaluate this from 0 to 2. Write this 5 a little bit better. Now, what do we need to do? We need to plug this in. This is going to be what? 2 to the 5th over 5. Now, everything in this second part is going to be 0. And why is that? Because 0 multiplied by anything is 0. So this is where we really have to be careful. Everything from this point is pretty much algebra. 2 to the 5th power is 32 over 5 minus. Now you have to remember, please excuse my. Sometimes that gets overlooked. So parentheses, exponents, multiplication. That's 2 cubed, which gives us 8. 8 times 8 is 64. So that's 64 thirds plus 32. Of course, that second part is 0. Now, I'm coming back to my scratch paper. So we know when we have a denominator of 5, a denominator of 3, and a denominator of an understood 1, our least common denominator is going to be 15. So that's going to give us 5 will go into 15 3 times. That's 96. Of course, you probably know this already, but I still just want to show every single step. 3 will go into 15 5 times. 5 times 64 is a negative 320. And remember, this is an understood 1. 1 will go into 15 15 times. 32 times 15 is 480. Now, what we do, we add up all of these like terms, and this is going to give us 256 pi over 15. Now, the main thing that we want to point out is, even though this is a calculus 2 problem, there's an emphasis on algebra. The only thing that you learn in Cal 2 that's relevant to this problem is actually the step where you find the antiderivative here. Okay, everything else is going to be algebra and things that you learned a long time ago, but have to be careful and just make sure we put everything together. So this is how we find the volume using the disk method going around the x-axis. Now, this is the difference in this problem that we have to do. I'm going to erase this.